In this video, we will try to derive the capacitance of a spherical capacitor. And what is a spherical capacitor? You just have a spherical conductor and you give charge to this conductor. And if you give positive charge to this conductor, all the charges will lie only at the surface and any electric field inside this will be zero. Suppose this is positively charged. In this spherical conductor has a positive charge and the positive charge is at the surface. Let the charge given is Q. And you need to have one more conductor should be separated by some distance. You consider a spherical shell and that spherical shell is given a negative charge and all the negative charge will be at the surface. And if the charge inside is Q, charge outside will be minus Q. And because of this minus Q charge, inside this region electric field is zero. So inside this, in this region, electric field is only due to this positive charge. You know that if there is a conductor, all the charges lie only at the surface, the electric field inside it is zero. Then the capacitance of a spherical capacitor is the charge built up by the potential difference between the plates. Now let's say the radius of the inner conductor is R1 and the radius of the outer shell is R2. At any distance R from the center, if you consider here electric field will be, because we know that electric field in this region is due to only this positive charge, and that electric field, if you give a charge to a spherical conductor, it behaves as if all the charges are at the center. If all the charge Q is at the center, it is like a point charge. At a distance R, electric field here will be equal to 1 by 4 pi epsilon naught into Q by R square. Then because of this charge Q, charge density developed. It's a spherical surface. Charges lie only at the surface. At the surface means it develops surface charge density, not linear charge density. It develops surface charge density. If sigma is the surface charge density, this charge density will be equal to charge by area. Then the total charge Q will be equal to sigma into A. Here also this Q is equal to sigma into A by the potential difference between the inner conductor and the outer conductor. Then the potential difference is actually equal to V between the inner and the outer conductor will be equal to integral E dot dr. If you move from here to here, it is plus E dot dr R1 to R2. If you move from here to here, you are working against the electric field, so it is minus where to where, R2 to R1, E dot dr. What is electric field at a distance R from here? Any typical distance? It is integral from R2 to R1 with a negative sign, 1 by 4 pi epsilon naught into Q by R square, because all the charge Q given behaves as if all concentrated at the center. Electric field at a distance R due to a point charge will be 1 by 4 pi epsilon naught Q by R square into dr. Then it is equal to minus Q by 4 pi epsilon naught will be taken out. Then integral dr by R square meaning R power minus 2 plus 1 divided by minus 2 plus 1. So this minus 2 plus 1 becomes minus 1. This minus 1 cancels with this. Then R2 to R1. Then what we are getting here is this minus and this minus will be cancelled. Q by 4 pi epsilon naught into this one will be equal to like 1 by R, because R power minus 2 plus 1 is R power minus 1. So 1 by R, upper limit is 1 by R1 minus 1 by R2. Here also the charge is sigma into A will come. Whether you choose to write sigma A or you can simply take it as Q by V, we will deal with this. So it is V, right? Then the capacitance of a spherical capacitor C will be equal to charge by potential difference. The potential difference is Q by 4 pi epsilon naught, Q by 4 pi epsilon naught into 1 by R1 minus 1 by R2. Q and Q will be cancelled, so it will be equal to 4 pi epsilon naught by 1 by R1 minus 1 by R2. This is a very important relation. Please remember, a lot of questions have been asked in that thing in competitive exams. The capacitance of a spherical capacitor is 4 pi epsilon naught by 1 by R1 minus 1 by R2. The other form is, if you write it, 4 pi epsilon naught by, if you just multiply R2 minus R1 by R1 R2, that R1 R2 will come over here, R1 R2. See, from this you can derive the capacitance of a spherical conductor and the capacitance of a parallel plate capacitor. You know that earth is to us, unless otherwise you go out and see, to us earth looks flat, because compared to the distances that we deal with, radius of the earth is so large. So for us earth looks flat. In the same way, for a parallel plate capacitor, you know that a circle of infinite radius is a straight line, a sphere of infinite radius is a plane. Then if you consider a very large spherical capacitor and the distance between the capacitors are so close, that means R1 is almost equal to R2, but they are not equal. Then R1 is almost equal to R2 means we can write it as R1 R2 as R square, where R is the radius, inner radius and outer radius are almost equal, then R1 R2 is R square. But since this is approaching the differential limit infinitesimally small, for infinitesimally small you can write R1 R2 as R1 plus delta R, then R square plus R delta R. R delta R is negligible, you can drop it. But R1 difference R2 or R2 minus R1 is not equal to 0, but it is very small r, delta R. Then in that case, the capacitance will become 4 pi epsilon naught, R1 R2 is R square, by R2 minus R1 is delta R. Delta R is the difference between the inner radius and the outer radius. If this difference between the inner radius and outer radius is so small, and if you assume that distance as d, then this delta R becomes d. 4 pi R square is the surface area of the sphere, and epsilon naught by delta R is the distance between them. So C will be equal to epsilon naught A by D. Now that we have derived capacitance of a parallel plate capacitor from capacitance of a spherical capacitor. Sometimes they will ask you, what is the capacitance of a spherical conductor? Suppose there is a liquid drop. What is the capacitance of that? For a spherical conductor, if there is no outer sheet, you can say that the outer sheet is kept at infinity. The outer shell is kept at infinity. If outer shell is kept at infinity, R2 is at infinity, R1 is the radius of the conductor. Then in this case, 4 pi epsilon naught, 1 by R1 is 1 by R minus R2 is at infinity. Then capacitance of a spherical conductor, if they ask, that capacitance will be equal to 4 pi epsilon naught R. You please remember these two results. Capacitance of a spherical conductor, no outer shell. In that case, it's a liquid drop, it may be a sphere or anything. That is 4 pi epsilon naught R.